Hey everybody. In class today we used the distributive property to simplify algebraic expressions, and we also talked about different parts of an expression, like coefficients, terms, and like terms. Tonight we're going to talk about a way to further simplify expressions and simplify some more complicated expressions by using what's called combining like terms. So if we have two like terms, like let's say 5x plus 6x, we can use the distributive property to work backwards actually and think about it like this. Because x is a factor in both of these terms, we can actually think about 5x plus 6x as 5 plus 6 in parentheses times x. Now using the order of operations, I can add 5 and 6 because they're inside the parentheses, and that will give me 11 times x. So really we can think about combining like terms anytime we see like terms as really just adding the coefficients. 5 plus 6 gives me 11, and we have 11x. Let's take a look at a multiple choice example. So we have this complicated expression right here, 4 times n plus 9 minus 3 times 2 plus n. And it's going to simplify into one of these very simple short-looking expressions. So we're going to use the distributive property, and we're going to combine like terms here to shorten it into one of these simplified versions. So I'm going to start by simplifying what we have over here on the left. I'm going to take this 4, I'm going to multiply it by both terms inside the parentheses. That's going to give me 4 times n plus 4 times 9 is 36. Now this part's kind of tricky here. I have this minus 3 times 2 plus n. What I'm actually going to do is I'm going to think about this as a negative 3. I'm going to do negative 3 times 2. That's going to give me negative 6, so I'm going to put minus 6. And negative 3 times n is negative 3n. I'm going to put minus 3n. So now if I want to, I can rewrite this so that this is just an addition problem. 4n plus 36, and instead of minus 6, I can put plus negative 6. And instead of negative 3n, I can put plus negative 3n. So now I have 4n and negative 3n are like terms. 4 plus negative 3 is 1. That gives me 1n. And I have positive 36 and negative 6. 36 plus negative 6 is 30, so plus 30. And that is my answer. So I'm going to circle B. Let's take a look at a real-life example here. Your daily workout plan involves a total of 50 minutes of running and swimming. You burn 15 calories per minute when running and 9 calories per minute when swimming. Let R be the number of minutes that you run. Find the number of calories you burn in your 50-minute workout if you run for 20 minutes. So the first thing I'm going to do is underline what I'm looking for, right? The S in the STAR process. So find the number of calories you burn in your 50-minute workout if you run for 20 minutes. Now I'm going to box the information I think I need. I know I need a total of 50 minutes of running and swimming. So that gives me the total amount of time. You burn 15 calories per minute when you're running. Need to know that. And 9 calories per minute when swimming. So lots of important information here. And then it says R is the number of minutes that you run. So I'm going to get rid of all this other information I don't need. And now we have all of our information. I'm going to use C, capital C, to represent the amount of calories I burn during this workout. Now I know R is the number of minutes that I run, and I know I burn 15 calories per minute when running. So the amount of calories I burn when I'm running is 15 times R. Now, that's just my calories from running. I'm also going to burn some calories swimming. So I need to add to that 9 times the amount of time I spend swimming. Now, if the total is 50 minutes, and I run for R minutes, the time I have left for swimming is going to be 50 minus R. So now I have this kind of complicated looking expression here, or equation, to show the number of calories that I end up burning. I would like to simplify this to make this easier for us. So I'm going to write C equals 15R, and the first thing I'm going to do is I'm going to multiply this 9 using the distributive property. 9 times 50, 9 times negative R. 9 times 50, let's see here, 9 times 5 is 45, so 9 times 50 is 450. 9 times negative R is negative 9R. Now, I can combine like terms. I have 15R, and I have negative 9R. That's going to give me 6R plus 450. And there is my simplified expression. Now, what we're looking to find is the number of calories you burn in your 50-minute workout if you run for 20 minutes. So remember, R is the amount of time we run, so R is going to equal 20. C equals 6 times 20 plus 450. 6 times 20, 6 times 2 is 12, so 6 times 20 is 120 plus 450. And we add those together, we get 570. So our answer is 570 calories.